All right, today we're diving into a paper from DeepMind that really, and I mean really, shook things up back in 2022. This research completely rewrote the playbook for building large language models, and it proved that when it comes to AI, being smart about how you scale is way more powerful than just raw size. So here's our game plan. We'll start by setting the scene, looking at the AI arms race of the time. Then we'll get into the big, brilliant question these researchers asked. After that, we'll uncover the new scaling law they discovered, see how they proved it with a new model called Chinchilla, and finally, we'll unpack the massive impact this all had on the field. To really get why this paper was such a big deal, you have to picture the scene back in the early 2020s. The entire AI world was basically chanting one mantra. If you want a smarter AI, you have to build a bigger AI. End of story. And that philosophy, it kicked off this crazy all-out arms race. All the big tech giants were just pouring unbelievable amounts of money and resources into one-upping each other, building these colossal language models, each one bigger than the last. Now, this is where it gets super interesting. Take a look at the pattern here. The model sizes, the number of parameters, they were just exploding, right? From 175 billion up to over 500 billion. But the amount of data they were fed, it was kind of stuck, just hovering around that 300 billion token mark. And that observation, that's what made the folks at DeepMind hit the brakes and ask a question that sounds simple, but was actually, well, revolutionary. It challenged everything. This is really the billion-dollar question, isn't it? Look, training these things is insanely expensive. It costs a fortune. So if you've got a fixed amount of cash, a fixed compute budget, are you really getting the most bang for your buck by just making the model bigger and bigger? Or is there a smarter way to play the game? So to figure this out, they didn't just guess. They ran this absolutely massive experiment. We're talking over 400 different models, systematically playing with the two big knobs, model size and the amount of training data. They were basically trying to draw a map to find that perfect, most efficient sweet spot. And what they found? Well, it didn't just tweak the old rules. It threw them out the window and gave us a totally new scaling law. See, the old way of thinking, the established rule, was that bigger is better, like way bigger. For every 10-fold increase in your budget, the model size should explode by about 5.5 times, while the data just inches up a little, 1.8 times. This paper basically came along and said, nope, that's completely inefficient, you're wasting your money. Their new rule was just so simple, it was brilliant. For the best performance, for the most efficient use of your resources, you should scale your model and your data together, in lockstep. You double one, you double the other. Simple as that. And just like that, the idea of compute optimal training was born. This was a huge mental shift for the entire field, moving away from this brute force obsession with size and towards a much smarter, more balanced strategy. Okay, but a bold claim like that needs some serious proof, right? You can't just drop a bombshell like that and walk away. So they built a brand new model, Chinchilla, specifically to test their theory in a head-to-head battle with the reigning champ, Gopher, using the exact same compute budget. So in this corner, we have the heavyweight champion, Gopher, a total beast of a model, rocking 280 billion parameters. This thing was the poster child for that old bigger is always better philosophy. And in the other corner, our challenger, Chinchilla. Now, following their new rules, it looks like an underdog, doesn't it? It's 4 times smaller, coming in at just 70 billion parameters. Now, Gopher, our champ, was trained on that pretty standard 300 billion tokens of data. But this is the secret weapon. This is where they flipped the script. Chinchilla was fed over 4 times the data, a mind-boggling 1.4 trillion tokens. Remember, same budget, just spent differently. Smaller model, way more data. And the results? Well, they speak for themselves. It wasn't even close. On all sorts of benchmarks, like the really tough MMLU1 you see here, the smaller, data-hungry Chinchilla just blew the giant Gopher out of the water, consistently. So this was way more than just one model beating another. This was a seismic event. The results, what people started calling the Chinchilla effect, sent a shockwave through the entire AI research community. So what's the big takeaway here? The paper proved that almost all the giant models of that era were frankly starving. They were severely undertrained. And just like that, the whole game changed. The race for the biggest model was over. A new, much harder race had begun. The race for the most and best data. You know, the Chinchilla story is such a great reminder that in a field moving this fast, even the things we think are absolute gospel can be completely overturned. It really makes you wonder, right? What's the next big assumption we're all making that's just waiting to be proven wrong? This is for entertainment purposes only.